Welcome back to Battleship Systems. Today we're going over everything you've ever wanted to know about fuses. Now I know that may sound like a mundane topic to you, but without fuses, battleships could destroy themselves in a matter of minutes. Now when we think about the purpose of fuses, we think about protection for something happening down the line like a short circuit or a motor burning up. And the fuses are there to protect the equipment and to protect us. But the actual reason for fuses are these guys here. Fuses are there to protect wires from getting too hot and catching on fire. The whole purpose of a fuse is to blow and break the circuit in the event the current gets too high. When we connect fuses to our lines, it allows us to use progressively thinner and thinner wires throughout the distribution system. For example, the battleship's power originates from a huge bus. If we connect a 100 amp fuse to that, we can use a thinner wire for our lighting panels. Furthermore, if we connect that to a 25 amp fuse, we can use a thinner wire for our feeder box. And finally, on the branch box, we can use a 5 amp fuse for our thinnest wires. In theory, if you had a bus bar running to every electrical component on a ship, you wouldn't need fuses. But that's not practical. Whether or not your home distribution box is a fuse box or a circuit breaker box, you're going to see big, thick wires going to high amperage loads such as stoves and air conditioners, and smaller wires going to low amperage loads such as the lights and outlets. All the circuits are using the same power. The only difference is the rating of the fuse or circuit breaker that is protecting that wire. So how do fuses work? So on battleships you'll see these cartridge fuses. Inside the cartridge is a thin metal wire which allows current to pass through. This wire is known as the element, and it's made out of an alloy that's designed to melt when the current running through it exceeds the fuse's rated limit. When too much current flows, a section of this element will melt, forming an arc. This arc works to burn off more and more of the element until the gap becomes so wide that it extinguishes the arc, and the fuse is blown. There are a number of reasons why fuses elements are always protected in these cartridge tubes. One is because the element is so fragile, even just touching it could break the circuit. Another reason is because when the fuse does blow, that element could go flying off and hit something else, causing a short. There's a lot of misconceptions about fuses' ratings and when they're designed to blow. Take this fuse for instance. It's a Fusetron 20 amp fuse. Now that doesn't mean it's going to blow when the amperage going through it reaches 20 amps. In fact, you could put 20 amps through it all day long and it'll never blow. Now as that current increases to 25 amps or 30 amps or even 60 amps, it's going to blow in less than a second. What happens if we send 21 amps through a 20 amp fuse? Well, that's a different story, and we need to consult the time current curve of the fuse. It could take 10, 20, or 30 minutes for the fuse to blow at 21 amps. Okay, so now you know that the more amps flowing through a fuse, the quicker it will blow. But in a ship with the hundreds of thousands of fuses, how do you know that one has blown? Well, fuses are silent, so unless someone tells you something's not working, you don't. To further compound the issue, many of the fuses for the ship's service system are held in these watertight and bolted down distribution or feeder distribution boxes. And even after you do get it open, you have to make sure everything is turned on, then use a voltmeter to find out if any of the fuses are blown. If you do get a voltage on one of them, that means the fuse is blown and needs to be replaced. Come on. Such is the life of an electrician's mate on a battleship. But what about fuses for systems that are so critical it could mean life or death in a battle? We're talking about interior communication power systems, such as the power system that controls the guns for the battleship. For example, when you go in the plotting room on the Battleship North Carolina, you will see these distribution boards. They run the entire height of the deck and are filled with nothing but switches and fuses. This allows them to quickly replace fuses during battle. You'll even see these handy fuse dispensers mounted on some of the panels so you can get fresh fuses whenever you want. For example, on the 1U system, the cease firing gong for turret 2 is protected by 3 amp fuses. Now obviously the most popular manufacturer of fuses you're going to see is Bussman, indicated by these bus fuses. This is a typical military style Bussman fuse. As you can see, there's no lettering on the body, but there's the rating, 250 volts and 30 amps, etched into each of the terminals. And they're 2 inches long. This green one here is a Shawmut fuse. This is a modern Shawmut fuse. As you can see, all the details are printed on the cartridge instead of the terminals themselves. These blue ones are Arkless fuses. Arkless is always an indicating fuse, which means that when it blows, a pin will pop out to let you know that this fuse is blown. In Arkless case, the indicator stays inside the unit, and you could see it through these holes on the top. Pretty convenient. This one here is made by the Commercial Enclosed Fuse Company, or CEFCO. Battleships always have the correct fuse amperage rating on a nameplate, but some of these nameplates can be kind of confusing. For example, this one says load and element. Sometimes you will see load and fuse. Or like this panel I found on a ship whose name I will not mention, just says L and F. So what does that mean? Well, the load represents how many amps is normally used by the equipment when it's running. The element, in the case of a circuit breaker, or fuse, in the case of a fuse, is the actual rating of the fuse or the circuit breaker. So in this switch, even though the equipment running only takes 10 amps, if any of these fuses are bad, you need to replace them with a 30 amp fuse. This leeway is provided not only to accommodate for the inrush of current for starting induction motors, but also for high loads on the motors as well that may cause increased amperage. The feeder for this panel, FB442, is protected by a 300 amp breaker. The circuit itself uses 200 amps. By the way, have you ever blown a fuse or had a circuit breaker trip, but you can never figure out what caused it? Let us know in the comment section below, and don't forget to like and subscribe. So why do fuses blow on battleships? Well, originally, the only reason that fuses would blow is because of faulty equipment or battle damage. But over the years, a new reason has cropped up that causes fuses to blow on battleships. And it has to do with our changing opinions on what constitutes a sufficiently lit room. When these battleships were designed in the 30s and 40s, they were designed to use incandescent bulbs. And at the time, people thought that maybe one incandescent bulb or one kerosene lamp was sufficient to light an entire house. But over the years, people wanted rooms brighter and more lights and more rooms to be lit. The Navy needed to accommodate for these sailors' changing views of what constitutes a sufficiently lit room. So they changed out the incandescent bulbs with lower wattage but brighter fluorescent bulbs. So for example, a lighting circuit that's designed for 10 60-watt bulbs might be protected by a 10 amp fuse. Well, the Navy says we can replace these 10 60-watt bulbs with 20 fluorescent bulbs that only take up 30 watts. And they replace it, and for the most part, it works. But now these ships are turned into museums, and the museums can't afford to light up that many 30-watt fluorescent lights. So these fluorescent lights are replaced with maybe 12-watt LED lights. And for the most part, it works. The compartments are now more bright than they've ever been before, and the bulbs, being fluorescent or LED, run cooler. But there's a big difference between the way an incandescent bulb uses AC power and how a fluorescent or LED light uses that same power. Incandescent bulbs are a purely resistive load. They don't change how the voltage follows the amps. But fluorescent lights, with their ballasts, are inductive loads. That means they affect the power factor. If you remember back to the video we did where we talked about power factor, a low power factor means the current lags behind the voltage. And that's what fluorescent lights cause the power to do. This means that they pull more amps before the voltage rises in the curve. Now when you see an incandescent bulb rated at 60 watts and an LED bulb rated at 12 watts, to get this wattage, they used a nearly perfect power factor. Now when you have a ship that uses hundreds or thousands of fluorescent or LED lights, you're going to change the entire power factor of the ship. And when you have a poor power factor going into those incandescent lights, they're going to pull more amps than they're rated. Now this may not cause any problems forever, but the phase of the light bulbs are going to be constantly changing, whereas the phase of the AC voltage is not. So there could be a time when all the phases of the lights become out of sync and draw more amps than that load is designed to handle, thus blowing the fuse. And again, it could be hard to hunt down where that fuse is and figure out which one is blown. Now there is something that battleships have that really helps with that situation. We're going to save that for another video. In lieu of donations to me, please consider donating to a battleship museum like the Battleship Alabama. There's a link in the description that'll bring you to the USS Alabama Battleship Foundation website where you can donate to the nonprofit organization. Don't forget to put Battleship Alabama in the comments of your donation so your money will go to the ship. Thanks for watching.